to Kim Show. It's great to have you all back here. Today's topic of discussion is application of Joule-Thomson effect in the liquefaction of gases. Okay, in this video I am discussing with you Linde's process and Claude's process. Okay, liquefaction of gas means what? That is, here gas is converted into liquid state. Okay, how does gas converted into liquid? How can we convert gas into liquid state? That is, by compressing the gas at temperature less than its critical temperature. That is, we are compressing the gas at temperature less than its critical temperature. That is the one method. And the second, the making the gas do some kind of work against certain external force, causing the gas to lose energy. That is, if work is done by the system, if piston is moving up, we had already discussed this part in the case of isothermal expansion. Okay, that is, in my previous video I had already discussed this part. That is, making the gas do some kind of work against an external force, that is P external, causing the gas to lose energy. Okay, third, making gas do work against its own internal forces, also causing it to lose energy. Okay, these are the methods of liquefaction. That is, we can convert gas into liquid state by reducing the pressure of the gas. One of the methods is reducing the pressure of the gas and decreasing the temperature. It is decreasing the temperature of the gas, and by Joule-Thomson effect. And by Joule-Thomson effect also we can liquefy the gas. Here in this video I am discussing with you the application of Joule-Thomson effect in the liquefaction of gases. That is, by Joule-Thomson effect we had already discussed that when a gas under high pressure is allowed to expand under adiabatic condition through a porous plug into a region of low pressure, there occurs a change in its temperature. There is a decrease in temperature. This phenomenon is known as Joule-Thomson effect. So, by Joule-Thomson effect, we can reduce the pressure of the gas and also we can reduce the temperature of the gas. Hence, we can liquefy the gas by Joule-Thomson effect. Okay. Let us see the Linde's process that is used for the liquefaction of gases. Okay. Here we can see the apparatus used in the Linde's process for the liquefaction of gases. That is compression pump, cooler, vacuum and a jet. Okay. Firstly, the pure gas, that is fresh gas, enter through an inlet to compression pump, where the gas is compressed to about 200 atmosphere. That is, where the gas gets compressed about 200 atmosphere and passed through a water-cooled pipe. Here we can see the water-cooled pipe to remove the heat of compression. That is, during compression, pressure is applied on the gas. When a gas is compressed, work is being done on the gas. That is, pressure is applied on the gas. The result of the work is first the decrease in its volume, and the work put into the system goes to increasing the temperature of the gas. That is, the temperature of the gas is increased by the compression. Okay. That is, to remove the heat of compression, we are passing that compressed gas into that water-cooled pipe. That is, here we can see the water-cooled pipe. Okay. Here you can see the spiral pipe. That is, it is then passed through a spiral pipe having a jet at the end. Can you see that jet at the end? That is, through the jet, the gas expands out into a region of low pressure. That is, in this process, it gets cooled. That is, when a gas under high pressure is allowed to expand under adiabatic condition through a porous plug into a region of low pressure, there occurs a change in its temperature. This phenomenon is termed as Joule-Thomson effect. That is, through that jet, the gas expands out into a region of low pressure, that is about 1 atmosphere. In this process, it gets cooled by Joule-Thomson effect. Okay, that is, the temperature of the gas decreased. Suppose from the beginning, if the temperature of the gas is 60 degrees Celsius, after this process, the temperature of the gases get reduced. Suppose it is 50 Kelvin. Then this cooled gas passes up over the spiral. That is, this cooled gas passes up over that spiral. Here you can see that. Okay. Thereby externally cooling the incoming compressed gas and is returned to the compression pump. Okay. That is, by repeating this process several times, a temperature low enough to liquefy the gas is reached and the liquefaction occurs. That is, this cycle is repeated, the temperature seems to be decreasing. And suppose if it is 50 Kelvin, now in the second process, if the process is again repeated, after the second process, the temperature was found to be 40 Kelvin. That is, it goes on decreasing and finally it reaches a temperature. That is, it reaches a lower temperature that is enough to liquefy the gas. That is, finally it reaches a temperature, lower temperature that is enough to liquefy the gas. And hence the liquefaction of gas occurs. That is, gas is converted into liquid. And the liquid collects at the bottom of the chamber from where it can be drawn out. Okay, you can see the liquid, that is liquefied gas. Okay. This process has been made use to liquefy almost all gases including hydrogen and helium. Next, we are discussing Claude's process. That is, in Claude's process, for the liquefaction of gas, the required low temperature is produced by two methods. Okay, that is, first method is to perform mechanical work in an adiabatic expansion engine, and second, to expand adiabatically through a narrow jet into a region of low pressure below its inversion temperature, that is Joule-Thomson effect. Apparatus for this process is same in the case of Linde's process, but the thing that is different is a piston. That is, here we are allowing the gas to perform mechanical work in an adiabatic expansion engine. This thing is only different. That is, when gas reaches this area, okay, when gas reaches this area, this piston moves upward. That is, some work is done by the gas in overcoming the intermolecular attraction at the cost of kinetic energy of its molecules. That is, here work is done by the gas. That means what? Work is done by the system. Here energy is released. This here temperature decreases. Hence cooling effect is observed. Okay. Remaining process is same as in the case of Linde's process. Let us see the process. That is, fresh air, the pure gas is compressed to about 200 atmosphere here in the compression pipe. Okay. and is then passed through a water-cooled pipe to remove the heat of compression. That is, during compression, heat energy is released. It is divided into two streams. One goes to an expansion engine, that is with the piston. Here we can see that. Does mechanical work by expanding adiabatically against a piston and thereby gets cooled. Okay, the gas gets cooled by expanding the piston. Okay, the other stream moves through a pipe and expands through the jet as its end to a region of low pressure. That is, low pressure means about 1 atmosphere, and gets cooled by Joule-Thomson effect. It is same in the case of Linde's process. Hence, the cooled gas is then returned to the compression pump. Again, the combined process is continued until a temperature, that is enough to liquefy the gas is reached. The liquefaction occurs. By repeating this process several times, the gas gets converted into liquid. Okay, Claude's process has been used to liquefy air and many other gases, including helium, which is the most difficult of all gases to liquefy because its critical temperature is very low. Okay. Here in this video, we had discussed the Linde's process and Claude's process for the liquefaction of gases. These two processes are very important in the examination point of view. Here is the notes for this topic.